Hi students, welcome. So e-commerce is always a favorite topic for the examiners who set questions both competitive and board examinations. So let us quickly recall the concepts and formulas that are related to e-commerce and solve some hand-picked 5 questions. Okay, fine. Okay, the answer is A. Okay, so the data that is given in the problem is percentage of oxygen is given and it amounts to 36.32 percentage. So I can also calculate a percentage of metal by just subtracting this percentage from 100. So percentage of metal is found to be 63.68. So from which I can calculate equivalent mass. Equivalent mass is equal to percentage of metal by percentage of oxygen into 8, or amount of metal by amount of oxygen into 8. So it is just like a 63.68 divided by 36.32 into 8. If I do that, I will get a value 14.02 unified mass, which can be approximated to 14 unified mass. Okay, this is our value. I can also use another formula, that is rate of diffusion of carbon dioxide divided by rate of diffusion of X, gas X, which is equal to square root of molecular mass of my X and molecular mass of carbon dioxide. Molecular mass of carbon dioxide. The values have been given. So I'm going to just substitute 4.7 by 4.6 is equal to root of molecular mass of X by 44, which is the molecular mass of carbon dioxide. So if I can also use this, and I can also simplify, the value will be very close to 14, and which we are not going to discuss this. We will be discussing this root when we discuss about the states of matter. So students, if you can able to find out the answer using this method, the first method, that is sufficient. Okay, right. Now let us see the second problem on our screen. Fine. The answer is C. Okay, students. So the given data is 0.20 moles of X2Y3. It weighs 32 grams. I am going to call this as equation number 1. And 0.40 moles of X3Y4, that weighs 92.8 grams. I am going to call it as equation number 2. Now I am going to process equation number 1. So I know that 0.20 moles of X2Y3 weighs 32 grams, which means I am going to calculate what would be the weight of 1 mole of X2Y3. So I am going to call it as X, and then upon cross multiplication I get this value, that is on the numerator 32 grams into 1 mole by 0.20 moles. So if I do this mole will get cancelled, which means 32 divided by 0.2, which will be equal to 160 grams. Okay. In the same way, I am going to calculate the second equation, that is 0.4 moles of X3Y4 will weigh 92.8 grams, and 1 mole of X3Y4 I am going to find out. I am going to call it as Y. Now upon cross multiplication, I am going to cross multiply this. So I am going to the value of Y. Y is equal to 92.8 grams into 1 mole divided by 0.40 moles, right? So this mole will get cancelled, and if I calculate this, I will get to 232 grams. Okay, fine. Now what I am going to do is I am going to call the atomic mass of X as M and Y as N. So I am going to assume like let M be the atomic mass. Okay, students, atomic mass of X and N be the atomic mass of Y. So I can coin equations like since I have X2Y3, right? I know the equations are two compounds are given, X2Y3 and X3Y4. So having these compounds in my mind, I can coin like 2M plus 3N, that is equal to 160 grams. Okay, that is 2x and 3y. Fine. So it would be amount to 160 grams. Likewise 3m plus 4n, that will be equal to 232 grams. Okay students, I am going to call these equations as equation number 3 and equation number 4. Now I have a different coefficients in the first equation and the second equation when I compare. So solving will be difficult. So we know the rules. So what I am going to do is I am going to multiply equation number 3 with 4 and 4 with 3. Okay. So if I multiply with 4, I will get 8m plus 12n, that is equal to 164 into 160 grams, right? I am going to call this equation as equation number 5. Fine. Likewise, equation number 4 is going to be multiplied with, equation number 4 is going to be multiplied with 3. Fine. In that case, I will get 9m plus 12n, that is equal to 3 into 32 grams. Okay. So I am going to call this as equation number 6. Equation number 6. Now if I subtract equation number 5 minus 6, okay, I will get the value of m. M will be equal to 56 unified mass. Now taking this value and substitute in any of these equations, 3, 4 or 5 or 6, any of the equation will fetch you a value of n, that is equal to 16. Okay, 16 unified mass. 16 unified mass. So that's the answer. Thank you guys. Okay, let's go to the third problem. Right, the answer is C. Okay, so it is given that hydroxide has 20% of oxygen and 4.29 grams of lower oxide. Upon reduction gives me 4.77 grams of hydroxide. So let us find out the answer for this. So I know that mass of oxygen in 4.77 grams of mx and OY. I'm going to call that compound as which is in higher oxidation state. Okay, higher oxidation state. I'm going to just abbreviate like this. So I can easily do that 4.77 into 20 by 100, because I know it is present as 20%. And if I do this, I will get 0.954 grams, right? 0.954. Okay. Now using this I can find out the mass of metal. Therefore mass of metal is just equal to 4.77 minus 0.954 grams, which will give me 3.816 grams. Now I know the mass of metal and mass of oxygen, so I can easily calculate equivalent mass, right? Equivalent mass is nothing but 3.816 divided by 0.954 into 8. So which gives me 32 gram equivalent. Fine. This is the equivalent mass of metal in a higher oxidation state. Fine. Right. Now for lower oxidation state, listen. For lower oxidation state, one thing is evident. My metal's mass won't change, right? So that is the important one. Metal's mass won't change. That's the important point you need to know down, students. So amount of oxygen in this one can also be easily calculated, because I know that 4.29 is the mass of lower oxide mass, from which I am going to subtract the known value, that is metal's mass. That will give me 0.474, which is nothing but amount of oxygen that is present in that. Now using the same formula, equivalent mass is equal to metal's mass, that is 3.816 divided by mass of oxygen, 0.474 into 8, which gives me 64 gram equivalent, right? So higher oxides metal that is present in higher oxidation state is 32 gram equivalent, and in lower oxidation state it is 64 gram equivalent. Okay, fine. Now let's have the fourth question on our screen.
Great. The answer is A.
So in the fourth problem, it is given that atomic mass of selenium is 78 unified mass, and we know that 0.5% of that selenium is present by weight in peroxidase anhydride and enzyme. So if 1 mole of peroxidase anhydride enzyme is weighed, then selenium is present in it. That is 0.5%, which will be amount as so I can write like this: 0.5% weight is that is 78 grams, right? 0.5% is 78 grams because 1 mole of it is present. So what will happen if I have 1%? 1% means I need to just multiply with the 78 into 2, right? So it will be amount to 156 grams. Then if 1 gram, 1% is 156, what about 10 grams? So the 10 grams is 1560 grams, right? What about 100 grams? 100%? 100% is, you need to add one more zero, right? Okay, so 15,600 grams. I can also write 15,600 grams as 1.56 into 10 to the power minus, 10 to the power 4 grams, right? So that's our answer, approximately 1.576 into 10 to the power 4 grams. It's very simple, students, because I know that 0.5% of percentage is the weight of selenium that is present in this one. So if I take 1 mole of peroxidase anhydride, my selenium, 78 grams of selenium will be present in it, which will be 0.5%. So what would be the 1% weight and 10%, 100% I have calculated. Very, very simple. Okay guys, let us have the last question on our screen.
Hope you would have solved. The right answer is C.
Okay. So it is given that 4 grams of my metal oxide M2OX that contains 2.8 grams of metal, and atomic mass of metal is also given 56 gram per mole. From the given value, I can calculate the amount of oxygen that is present, amount of oxygen or weight of oxygen that is present. It is very simple. I need to subtract from 4. So 4 minus 2.8, that gives me 1.2 grams of oxygen. This much oxygen is present in 4 grams of my metal oxide. Now what I am going to do is, I am going to calculate the number of moles of my M2OX, 4 grams, okay. 4 grams is how many moles that I am going to calculate. Fine, students. So the discussion goes like this: 1 mole of M2OX, okay, this contains, it contains 2 metal ions, right? 2 metal ions, and I need to retain this in my memory. So 1 mole of M2OX that weighs 2 into 56 grams of metal. Am I right? Because 2 metal ions are present in my metal oxide. That's why. So which means 2.8 grams of metal is how many moles? That's what I am going to find out. I am going to call it as X, and then upon cross multiplication, okay, then upon cross multiplication will give me the value of X, that's the number of moles, that is 1 mole into 2.8 grams, fine, 2.8 grams divided by 2 into 56 grams. So these grams will get cancelled, and I will get 1 by 40 moles. I am not going to simplify this. 1 by 40 moles. Okay, now the next part of our discussion is 1 by 40 moles, right? 1 by 40 moles of metal oxide, that is M2O3, right? M2O3, it has some 1.2 grams of oxygen, which means 1 mole of M2O3. 1 mole of M2O3 will contain how many moles? That's what I am going to do. And again the same principle, cross multiplication, which will get me X is equal to, so 1.2 grams, fine, 1.2 grams into 1 mole divided by 1 by 40 moles. Fine, this moles will get cancelled, and this upon calculation. When you do this calculation, 1.2 into 40, this is what I will get, which will be amounting to 48 grams, right? And now how to calculate the number of oxygens. We know 16 is the atomic mass of oxygen, so X can be found out by just dividing this 48 with 16, which will give me 3, which means I understand that there are 3 oxygen atoms present in the metal oxide. So that's our answer. Thank you guys. Happy learning, and please do subscribe our channel. Please share it to your friends and give your feedback in the comment section. Thank you. Happy learning.